log 36 base 6 equals 2. Logan. Exponential form.
6 squared equals 36.
6 squared equals 36. And make sure that the equation still is true. So they're just two different ways of saying the same thing. The top one says 6 to what power is 36, and that number is 2. 6 squared equals 36 means the same thing. All right. Scott, second one. How can we check these out? We can either dump them in Desmos, or we take a look at our little cards. Okay. So just go in our head. 3 times 3 is 9, times 3 is 27, times 3 more is 81. Next one's a bit confusing. You've got to remember something about fractional exponents. Remember, Angel? What do I start with? Matthew.
The square root.
Ooh, square root of what?
289.
So first I'm going to write it as a fractional exponent equals 17. But as Matthew had stated, it really means the square root. Okay, so I'm going to leave this here and just rewrite it down here. So square root of 289 equals 17. And if you didn't know that, you can look it up on Cami, because your little card only goes up to 10. Any other questions? These ones? These are the easier ones because you know what the base is. These ones, the log thing, remember it said it's kind of like driving in reverse. A little harder. But it's easy enough to set up. So logarithm, log, base what? Read out.
Base is 12.
12, because it's attached to the exponent of 144. Because remember, the logarithm is equal to the exponent. Okay? All right, next one. Just breathe. Step breathe. Nine. Keep going. Okay, so let's pause for a second. Watch what happens. Ready? 1. Oh, man. Swiper, no swiping. Okay, so how do I take care of this? Highlight the 1, or I could put it in a parenthesis. Okay? Either one works. All right, keep going, Bree. Yep. Remember, the logarithm is equal to the exponent. Just that's the mantra that's in your head. And last but not least, all right, Ahmad, go. Log base B, because B stands for base? No.
Let's go.
B is the exponent. What's the base? 8. Okay. Now B? No. He just doesn't learn, does he? How did I do that? Okay. Well, if it's not B, log base 8, so this must be A. Yes? So log A base 8 or log base 8 of A equals B. Because the logarithm equals the exponent. All right. Today's lesson's actually pretty simple. It looks complicated because we're solving logarithmic equations. And we haven't done this before, but you really have. What did we just do with log equations? We changed them to, have we solved exponential equations before? Yeah. So, what's my base? 4. What's my exponent? To the x plus 5. Take your little cards out. If you don't have one, take out Desmos. Okay. I'm going to do a little Control A, Control C, Control V action. Okay. Look on your card. What row should you look on your card? 4th row, because I'm on base 4. What column is 1024 in? 5th. So I change my 1024 to 4 to the 5th power. And now since my my bases are the same, my exponents will be the same. Okay? So x plus 5 equals 5. This is now a middle school math problem, right? What do I add to 5 to get to 5?
5.
No, 5 plus 5 is 10.
And
And then I can double check by actually plugging them back in. So I will make an official checks box. I'm not going to ask you to do this all the time, but I think it's important, especially when we get logarithmic answers, because sometimes, hey, what happened when we solved square root problems and rational problems?
get
We got that
false.
false or what's called an extraneous solution.
Yeah.
Do you think that might happen today? Yeah, once or twice.
I don't want it.
Oh well. All right. So since I'm in a text box, I'll make my equation here. Does log underscore base 4 of 1024 equal 0 plus 5? Well, remember, a logarithm is just an exponent. What exponent? Well, I look on my little card, look at row 4, and go over to C1024, and the column number is my exponent. So what is log 1024 base 4? That's 5. Okay. So 5, and what's 0 plus 5? 5. So 5 equals 5. I know my answer is true. So you know me, I like to go back over here, go to the paint can, and this means I have checked the problem. Now, I recommend at least checking in your head. I don't physically need to see the check unless on a quiz or test I say show the check. Okay? But a couple of these today, we're definitely going to be doing the check. Turn it off. All right. Take a moment, see if you can do this one on your own. Remember on the bell work, after we change it into an exponential equation, if we have a fractional exponent, we need to do something else first before just saying, oh, that looks pretty. Let's just leave that alone. No. Anytime I see a denominator, I need to think a radical. In this case, what's it going to be, Santiago? What's the radical I'm going to be using here? Square root. So x equals square root of 16. And then I take that whole thing, and I still got that fifth power there to the fifth power. Can I do this on the card? Yeah. Look at the second column. Go down and find the 16. Go to the left, you got 4. So that really, this is just x equals 4 to the fifth power. And I think we just did that, didn't we? That's 1024. Okay. So take fourth, go to the fifth column, and that's your answer. Okay. And you can double check. Ready? Go to Desmos, since this one takes a little bit more work. Log underscore 16, 1024, 2.5, which as a fraction is 5,000. Okay. So again, I don't need to see the full check, but at the very least, either dump it into Desmos or go through it in your head, make sure it makes sense. Okay. In this case, I don't think anybody in here knew that the log of 1024 base 16 was actually 5/2, so might want to use Desmos for that one. Okay. Except for Derek. I know Derek knew it. All right. Try that one.
I gotta see how much.
3 to the power of x minus 4 equals, remember, no more logarithm, 243. Change 243, so we're going to do 2 steps in 1. We go to row 3, go find the 243, and then it's 3 to the 5th. And then x minus 4 equals 5 because our bases are the same. And that means x equals 9. And if I plug in 9 minus 4, I get 5. What power do I take 3 to get 243? We just did it, 5. Okay. So again, I don't need to see a formal check unless you see it on the test, but make sure you at least walk through it. All right, try those two. Similar idea. All right, here we go. 9 to the 3/2, which is really square root of 3, square root of 9 cubed. Can we do this in one step? Yes, sure. X equals square root 9. Come on, square root, square root, square root, square root, square root. Square root 9 to the third power. Square root of 9 is 3. 3 cubed is 27. Okay. This one, a little bit more work. 4 to the power of x minus 2 equals 4 to the third power. So that's really x minus 2 equals 3. And that's going to be 5. I would take a moment and check these. So I would do log 27 base 9 in Desmos. So log base 27 of 9.
927.
Yeah.
Oh, flip it.
Flip it. So log 9 of 27
Yep, 1.5. That's
is 3 halves. Okay. And then this one you could probably do in your head. 5 minus 2 is 3. 4 to what power? 64. And that's 3. Okay. All right. They're going to look more complicated now, but they're actually easier. Okay?
Yep.
This is just like having the same base on both sides. So when I have a logarithm on both sides,
Just do the.
I take, ready, big fancy word, the anti-log. And we're going to talk more about this when we talk about the logarithmic properties tomorrow or Friday. But really, all you're doing is just pulling them apart. So you have 2x minus 10 equals 2. This is a middle school math problem. Take you about 10 seconds, maybe 20 or 30. Mr. Arroyo.
Just weird. Does anti-log sound like some cheesy, like log chopping business?
Cheesy log chopping business? It's very serious business.
Anti-log.
Anti-log.
Get rid of
See, when I hear anti-log, I'm like a Star Trek freak. So what do you think I'm thinking of? Antimatter. There you go. And antimatter is badass. That's actually something that's real. And if they ever get to use it, yeah, it'll change. Okay.
Whoa!
Oh, yo.
Add 10. Divide by dose. 2x equals 12. Divide by 2. And I got myself an answer of 6. This one is one of those ones you probably could just check in your head. 2 times 6 is 12 minus 10 is 2, and that's a log 2 base 5 on both sides. Done. Okay? Query. Logarithms. Can I ever not take a logarithm of a number? Think about it.
Wait, can I say it again?
Think about it. Can I ever take a logarithm? Are there any numbers I can't take logarithms of?
1 and 0.
All right, do that one. Should take you another, I don't know. This might take you 30 whole seconds. Go. So negative 9x. So this one, the only one that makes this a little tricky is some people were fooled today into thinking, oh, there's 80 and there's 1. That makes 81. But
Who would do that, bro?
Yeah, who would do that?
you're supposed to subtract the 1, not add it. Okay, so that's negative 9x equals 79. And why does that completely change it? Because 79 is prime good time. Prime. So my answer is negative 79 ninths. So like I said, this one probably might take you a little longer to check. All I need to do is do this part right here and plug in the negative 79 ninths. So I'm just going to make a little equation box over here and not even call it a check. So negative 9 times negative 79 ninths plus 1. Well, my negatives divide out, my 9s divide out, and 79 plus 1 is 80. And I have log base 7 of 80 both sides. Good to go.
Wait, can I see that?
Sure. Okay.
Wait. Dash.
Questions? So be careful when the numbers look too good to be true. Sometimes they are. Okay. So if you got an answer of negative 9, you know what the thing is? You're not off by much. You're off by 1/9.
So that's 88, right?
Or 2 ninths. That is an 80. I'll make it look prettier. Like I said, I don't write as pretty as my best friend growing up, Phil. He would have made that much prettier.
Oh, wait, so it's 88.
And he's not just a pretty writer, he's a smart guy.
Wow.
He's a director at Stanford.
What a nice guy.
He's a really nice guy.
How many songs were these?
All right, they're gonna get a little harder.
Oh, this is one of those.
Okay, so we still take the logs out, but you got to remember something. This is no longer a middle school math problem unless you took algebra 3 in middle school. Some of us did.
Did you?
Well, 9th grade.
What a dope.
But not the bribery.
Not the brag. Well, my friend Dwight Wilson, so I took algebra.
We're all your friends, bro.
My friend Dwight, he was in my 7th grade algebra 1 class. In 8th grade, he skipped geometry, algebra 2, which we called it algebra 2, and pre-calculus, and went to my sister's BC calculus class as a 13-year-old. He never graduated high school. He didn't see a need for it. He went right to college when he was 15.
How rich is he right now?
Well, he's dead now, but
How rich can I be?
before that, he was pretty rich. He had his own software company. He died of cancer. All right, here we go.
I did it one way.
It's a quadratic. Quadratic. So what do we got to do?
Yeah.
Set it equal to.
Zero.
So subtract x. But Dwight was an awesome dude. But back in the 70s, there used to be these posters of nerds where the kid was in black pants that were kind of a little short and had the belt on there and the
All the classic
calculator
nerds.
attached to the belt and the pocket protector all the way to the top, horn rimmed glasses. That was my friend.
How long ago did he die?
He was in his 40s,
Oh, that.
so like 10 years ago.
So I never heard about the 50 manga.
Nah.
Why would
All right.
you say that?
How many answers?
Oh.
Dose. So we got 0 equals. Take a moment. My favorite math F word, factor it. Find your answers, and you have to check these. You just have to. You will not know what happens until you check. Okay, so we're looking for two numbers that multiply to be -2 and add to be -1. So really I only got two choices. It's 1 and 2. I just got to figure out which one is negative. How did you figure out that the 2 is negative, Rita? It's just a lucky guess. Yeah? Okay. So this sign right here, the negative, tells me the number furthest away from 0 has to be negative. So that's why the 2 is negative. Okay? At this point, I use the 0 product property, which states if I got two things and they multiply to be 0, one of them's got to be 0 at some point. So at some point, x minus 2 has to equal 0, or at some point, x plus 1 has to equal 0. Now, I don't need to see all the breakout each time, but I would recommend at least doing it once. So here, x is 2. Here, x is -1. But let's check the 2 first. Plug it back into the original. Okay. So all you got to do really is the right-hand side. 2 squared is 4 minus 2 is 2. So I got log 2 base 3 on both sides because I got a log 2 on the left. So that one works. Bueno. Okay. Remember I asked about can I take logs of certain numbers and not certain numbers?
Yeah.
Yeah, when we first started talking about logarithms, we said you can't take logs of
0.
it'll look negative. If you didn't remember this, what you just do, go to Desmos and plug in log base 3 of -1. Okay? So log base 3 of -1. Hey, it tells me it's undefined. Because really, a logarithm is n 3 to what power equals -1? You can't. 3 is positive. -1 is not. So, light x, go here. This one works. And if you want to be extra,
Could x ever be
Because it
negative?
was my
hold on to that thought.
Because it's
Stealing my thunder.
Yeah.
Try the next one.
Oh, that's. Oh.
See?
What's that, offline mode?
So, log 5 goes bye-bye. Negative x
My camera broke.
equals x squared minus 20. But I need to set it equal to 0. So I need to add x to both sides. Some of you subtracted x. If you did that, then your answers are going to be wrong.
Can't just shut down, bro.
So 0 equals. We do this in order from the highest exponent down to the lowest. You with us, Gage? So x squared plus x minus 20. So we're looking for two numbers that multiply to be negative 20 and add to be positive 1. So I've got 1 and 20, I got 10 and 2, I got 5 and 4. Really? When the sign is negative here, right here, it's not going to let me highlight it, but you can see it, then that means the numbers have to be this many apart. If you don't see a number, the number is really 1. So 0 equals, it's going to be 5 and 4. The 5 has to be positive, and 4 is negative.
Mr. Look, Cammy just broke.
Oh, you broke it. Cammy doesn't break.
Cammy
It
just
does.
broke.
Well,
It
it
doesn't
could
let me
be.
say.
I got offline mode.
It doesn't let me say what you say.
All right, you know what?
I
I'm scared.
Folks at Cammy are in like this conference now, so maybe that's what's going on. They're all like partying and stuff.
That's what I mean. So hopefully.
Oh, there we go.
Let's go. I absolutely in it. Let's go.
That's okay.
No, it's not.
Oh, what?
I just refresh your page.
The Cammy server is
I'm not refreshing my page because get deleted.
It should save it. It auto saves.
Yeah, it says it saves once it'll go back online, it'll save.
Yeah. Anyway,
Yeah, it booted it all.
so we're just gonna stop here for now, and I'll do the rest on the board.
Do you want